Okay, 37 again, Kramer rule. I set out the determinant of the system D. Let me try to expand using the row 1 again. This is 1 multiplied by determinant is formed by 1, negative 2, negative 4 and 6. Now negative 2 is plus 2, determinant of 3, negative 2, 2 and 6. Finally plus 3, and determinant is 3, 1, 2, negative 4. Let's evaluate that. This is 6 minus 8 plus 2 times. This is 18 plus 4. This is 3 times. This is negative 12 minus 2. So this is negative 2 plus something. This is 22 times 2 is 44. This is negative 14, and negative 14 times 3 is negative 42. Those negative 2 plus 44 is positive 42, minus 42 is 0. Wow, when it's 0, of course, is no applicable. No applicable, the Kramer rule. Okay, again, 39, Kramer rule. This is the system, and this is the determinant of the system. Let's compute it by hand. And after I want to show you how you compute it by calculator. And finally, we're using some property to simplify our problem. So let's do in the expansion for this determinant by the row 1. So it is negative 4, 1, 2, and negative 3. Minus 2 times 2, 1, negative 2, and negative 3. Minus 1 is the third entry in this row. 2, negative 4, negative 2, and 2. Okay, let's go to the multiplication. This is 12 positive minus 2. Minus 2 times, this is negative 6 plus 2 minus, this is 4 minus 8. Okay, this is 10, and this is negative 4 minus times negative 2 is plus 8, and this is negative 4 and negative plus 4. This is 12, it's 22. So D is 22. The determinant of the system is 22. I want to check it using the calculator. Suppose my calculator here. Okay, I omit the process of the addition of the matrix. Okay, I suppose you know for the previous section. So directly I have my matrix, the matrix A associated with the problem is 2, 1, 2, negative 1, 2, negative 4, 1, negative 2, 2, and negative 3. So it's easy, super easy. You go to the second matrix, mathematic, and select the option 1, which is DET. DET of the matrix A, you select matrix A, close the parenthesis, and the answer is 22. Wow, it's amazing. Okay, so now, for finish our problem, let me compute the rest of the determinant. But what is the most important property we're using to do fast this problem? So you replace, for example, dx. Dx is equal 1, 2, no. You replace the right hand side, is just 0, 0, 0, by the column of the x. is 0, 0, 0, and the rest stay the same. 2, -4, 2, -1, +1, and -3. Okay, so there are one property of determinant in which if you have one column or one row completed of the 0, the value of the determinant is equal to 0. And this is obvious to prove because you expand using this column. 0 times something plus 0 times something plus 0 times something is 0. Likewise, dy is 0 and dc is 0 because dy is formed by the second column and dc by the third column. So now it's obvious that any value of the x dx over d is equal to 0 over 22, que is 0, and likewise y and c. Now the only point, the solution for the system is 0, 0, 0. Okay? Okay, 41, this is the system, and this is a matrix, the determinant associated with this matrix, this system. In this case, I want to compute directly using a calculator. I edit this matrix inside the calculator, matrix A. 1, -2, 3, 3, 1, -2, 2, -4, and 6. I compute the determinant using the calculator. Mathematic option 1 of the matrix A. And the answer is, wow, it's 0. Since 0, guys, you know, the grammar rule is no applicable. It's not applicable. Okay, that's it. And in this case is using property of the determinant, find the value of each determinant. If you know, so it's, you know this, okay, this determinant is equal to 4. This information is given, and after you find that. Now what is the key idea? The key idea is you try to manipulate this determinant in order to express a similar or equal to this. I saw the difference. Well, what is the difference? The difference is, can you swap the row 1 and the row 3. So we have 1, 2, 3 here, UVW stay, and we have here X, Y, and Z. I know that when this situation happens, when you interchange two columns or two rows, any two columns arbitrary, the new value of the determinant is negative. And see, this value is 4 because it's given, the answer is -4. That's it. Okay, the same problem. Using the property of the determinant, find the value of this determinant. You must do properties. One property, the property number 3 says that when you multiply any column or any row by a number, the value of the determinant is multiplied by the same number. Now I saw here okay, we have -3 like a common factor. I factor out, okay, entonces es X, Y, Z, and we have 1, 2, 3, and UVW. Finally, you must interchange, in this case, row 2 and row 3. So we have -3, but when you interchange, you must multiply by -1, it's +3. So we have X, Y, Z stay the same. Now you have UVW here, switching this and this, and 1, 2, 3. And this is identical to the given indeterminate is 4, and the answer is 3 times 4 is 12. Super. Okay, again use the property. There are many ways to do it. I saw, for example, the third row, you have two common factors. I put outside. We have 1, 2, 3, x minus 3, y minus 6, z minus 9, and we have UBW. Okay? After that, I propose you, for example, the following row operation. Suppose we are doing this row operation. 3R1 plus R2, store this information in the R2. Basically, I multiply by 3. 3 times 1 is 3, plus this, it cancels out, positive 3 and negative 3. So we have 1, 2, and 3 stay the same. When you perform this row operation, you have only x, y, and z. Because 3 times 1 is 3, plus x minus 3 is just x. 3 times 2 is 6 positive, and minus 6 is 0. And 3 times 3 is 9, minus 9 is 0. And UBW. And remember, don't forget this too. When you perform row operation, the value of the determinant stays the same, doesn't change. Okay, finally, I want to switching, for example, I switching, let me see, I need XY in the first one, why not? I switching row 1 and row 2. So we have minus 2. Remember, when you interchange the row, you change the sign of the determinant. It's x, y, z. 1, 2, 3, and UBW. And finally, why no? R2 and R3. Again, change the sign of positive. X, Y, Z, UBW, 1, 2, 3. It's exactly the original determinant, because the answer is 4, and the answer is 4 times 2 is 8. Okay? Okay, 49 is similar. Again, I saw, okay, 2 is common factor in row 2, I put outside. 1, 2, 3, X, Y, Z, U minus 1, B minus 2, and W minus 3. Okay, again I saw a row operation. It is row 1 negative plus row 3 store in the new row 3. Basically subtraction, but subtraction in a different way. Multiply by wait, this is positive here. Addition, R1 plus R2. This is 1 plus U minus 1 is just U. So row 2 stays the same. Row 1 stays the same. Row 2 stays the same. However, row 3 change. You adding this plus this is cancels out, negative 1 and positive 1 is just U. Likewise, this is just B, and this is just W. Okay, and the answer stays the same. Don't forget these two, it's a factor. Okay, we factor out. Now, what should I do? What should I do? You, for example, interchange again row 1 and row 2, no? Let's see what happened. This is minus 2. This is X, Y, Z, 1, 2, 3, UBW. Okay, no problem. After that, you interchange row 2 and row 3 again. Let me see if it works now. Oh yes, 1, 2, 3, So this interchange again positive. It's X, Y, Z, UBW, 1, 2, 3. And the answer of this is 4 times 2 is 8. It's a little bit similar.